So hey guys, we are back with another video, and in this video we are going to talk about text classification in 2025. You know, text classification is a very basic task of NLP. When you start your journey towards AI, ML and NLP, you will see that this is the first task you usually work on after a basic classification task of ML models, traditional ML models. So in a glimpse, text classification is an NLP technique, right? That involves assigning predefined categories or labels to text data. Let's say the basic example is sentiment analysis. You can either keep it neutral, you can either keep it positive or negative. Now when a text comes, the model analyzes the text, and on the basis of the words and calculation it does, it will provide you an output that can be -1, 0 or 1, that is numerical output, or it can be positive, negative or neutral, a text based output, right? So in 2025, the main purpose is how many things are available right now. This video is going to be mostly available at the end of 2024, but yeah, a glimpse of 2024, that how many techniques are now available, consisting of representation models. We have the generative models. So 23 and 24 are going to be considered as a boom age of AI, and the traditional NLP to generative AI part. So yeah, let's start with the dataset part, right? This is a Google Colab notebook, and I'll provide you the link to this notebook in the description as usual. For the first thing that we need to is install the datasets library that is provided by Hugging Face, and I'll hide this. Now we need to next do the next thing as importing the load dataset class. Now after this, we are going to go through the Rotten Tomatoes dataset. So this dataset is all about movie reviews and everything. So we know that on Rotten Tomatoes you can go and write a review. So same thing is happening here. They have a set of reviews of customers that they come there, of users who come there and write reviews. Okay, I like this movie was fantastic and stuff. So I'll load this dataset, Rotten Tomatoes, and yeah, once it's done, the next thing that we are going to do is define that how many things we are going to use. So it's done. Here you can see in the training part we have 8500 sets, and in validation 1000, and same in test data 1000 around. Now for the first thing that we are going to do is we will be using representation models. Now this representation models comes in two ways, right? One which are specifically fine-tuned for a task, and one are embedding models, which are actually going to represent your text in a particular way, and through that you can do all the calculations and similarity. But right now let's use the method 1 as the one where a particular model has been trained on this. So let's start with this. If you see here, it's about my card NLP, and the model name is Twitter Roberta base sentiment at latest. Okay, now this model is based it's a Roberta based model trained on 124 million tweets from January 2018 to December 2021, and fine-tuned for sentiment analysis with a Twitter eval benchmark. Seems pretty good, and the number of downloads of the model is too high. You can see it's more like 28,84,000. Yeah. Now let's go here. So from the transformer, we will import the pipeline. We will provide the model path. Once this is done, we are going to define the pipe here. Here we will be putting the model path. The tokenizer, it is going to remain the same, and return of scores equals to true, device is CUDA, because we have a single GPU here. And okay, the point is how things are going to work out. You can see like this. We have a structure here. The first one is the text, right? It goes to tokenizer. The text is broken into small tokens. These tokens are then processed by this model, the model that we are providing here, and all the calculation that is done, once done inside the model, all the prediction and everything, it will give us our output that is going to be, it is positive or negative. Okay. Now negative score is obviously this, you can see, and this is the positive score. We are going to iterate through the whole data set, and we'll get the results from here, the numpy argmax, and then we are going to append it. Cool. So it's pretty clear, right? We are passing one by one row to the model, and then we are getting the output and we are storing it. Okay, cool. It will take, I think, not more than 1 minute, or maybe 35 seconds are more than enough. Now from this, we will be going to produce a classification report. This is how it looks like. We have the why true, the target name are negative reviews and positive reviews, right? This is, I think you all know the confusion matrix, right? That is the most important aspect when you learn the very basics of traditional NLP. So let's produce this. We have defined this, and we have the results. The precision, recall, F1 score and support. Okay. So if you see 0.76, now I will write to you some notes that I made. I remember the last time we have been talking about this, I saw some difference in the score. Can this happen every time? Yep. There is a slight possibility in generative AI models that things can happen different, but in representation models you won't see that much. Okay, now if you see here, the precision, recall, F1 score and support are there, and these things, micro average, weighted average, you will see. So overall, if you want to see, you can say 0.76. That is a number you can say. So because if you go by accuracy, right, you'll see that most of the time accuracy won't help you much. So because what happens is you want to see the false positive, false negative, true positive, true negative. Sometimes that is how you get to know how your model is actually performing on negative samples and positive samples simultaneously, right? You want to know that. Now the second method is using embeddings. Now for embeddings, you guys can go and check this MTEB leaderboard by Hugging Face. You have the best top embeddings here. For now I will be using this one. This is sentence transformer all MP-NET base v2. Okay, it's a good model. If you see it, you will be able to find it here also. I am using it because it's very very small in size, and it is only I think 500 million parameters, something like that. Yep, 438 MB, right? Yeah. So 438 MB is the size, and let's go. We'll be taking it through sentence transformer. Okay, and then what we will be doing, we will be doing the same thing exactly that we did before, but bit differently. Okay, we are going to take the model, the text that we have, we are going to encode it. That is, we will have the embeddings of all the model of the the text that we are passing, and then on the basis of that we will get results. Okay, cool. Here you go. So here we are encoding the data, the text, and then same thing we are doing for the test data. Okay, once we have that, what we will do, we'll get the training data and actual label data, and then we are going to fit a model, a logistic regression model here, and we will check how good it is performing. Cool. Now we have the embeddings, right? These embeddings will have different shape. If you want to see, I'll try to, but I think it's not gonna work that way because seeing them, it's quite difficult. Okay, good. Yeah. Now here's the catch, right? When you want to see the embeddings, I'll show you. You'll see it, right? Why didn't it work? I want you guys to comment that in the section, right? Why didn't that thing work? Because if you want to see, you will see that most of the time these embeddings are 32 by 8, right? If for this particular case. Now let's look at the results, right? Let's look at the results, and I have the results written with me alongside. That what were the results that came last time? We have the logistic regression model trained here, and now we'll do the evaluation performance, right? Cool. Okay, I have the results, and if you see 0.85, 0.86, I think every time the results are matching, right? They're matching. So you see, in most of the cases when generative AI, you are not changing the temperature and randomness, right? The results are going to remain same in that also, but in representation models, you won't see the difference, right? Even if you run the same thing again and again, because these embeddings remain same all the time, right? The model that you train, maybe the slight variation can be there, but you won't see the difference in the result that you often see many times in some models, right? Now coming to this, right, because it's not an object, and if I think I do this, we will be able to see the shapes, right? This is 8530768, right? So you see guys, we have a defined set of dimensions here that that can be used for all the purpose here. We have the data, we have shape here, and that's how we get a vector. So I think most of you guys have already got an idea why that shape didn't work, because I was expecting that many times it happens when I'm talking to friends that it is acting as a tuple or it is a list. No, it is not that, right? It is an array of list. Okay, cool. Let's go to the next part. What if there is no label data? What is going to happen then? Okay, in that case, we are going to have the label embeddings, a negative review, a positive review, because if you don't have label data, what you can do, you can have what is positive, what is negative, create a embeddings of these two things, right? And on the basis of cosine similarity, you can compare every text with these. Now what is cosine similarity? On a graph, if you take and you bring two lines, right, one at 80 degrees, one at 65 degrees, the angle between them is always difference, right? This difference as close as possible could be that we are going to consider. Suppose this embedding has a difference with this positive as 30 degree and with negative as 65 degrees, which we are going to consider positive one, right? So how close is that to positive, how close is that to negative? That we need to check, right? That is where we are going to, we already have the embeddings here for train and testing. We are just going to encode these two, right? Yeah, we have encoded negative review and positive review. Okay, now let's do same thing we are doing. We are just, instead of the data that we have the labels that we have, we are taking these two things. Cool, I think we are good to go. And yeah, you see the results here. You will see the difference, 0.78, and I think it was 0.85 here. Obviously, there will be a slight difference. And I think if you guys go to this one, right, this MTB leaderboard, if you take the top model here, maybe you'll see that, okay, the difference is less there. So it totally depends on the model. But I think this current model that we are using is also pretty strong. And that's the reason you, even without labels, you will see that the difference is very less, right? 0.85 and 0.78. So yeah. Now, the last thing in the coffin, right? Using a generative model. I could have used ChatGPT here. You guys can go and put this data on ChatGPT and you can generate from that also. That's pretty cool. Now, what I'm going to do, I'm going to use this Google Flan T5 small. Okay. It's a very old model. If you go to the files and version, you'll see that it is about 2 years ago. So it's a small model. This Flan T5 series by Google, right? It was, I think, released 2 years back, and it got pretty famous in, I think, 22 end, and everyone was talking about it. Even though after a while, when new models came, everyone forgot about it. But I would still say it was a pretty good thing, because if you read the paper and everything, you learn a lot of new things, right? I even right now have the T5 paper with me. Now this is a small model, so we can load it on Google Colab. This won't be an issue for us. That we are going to do text to text generation. The model is Google Flan T5 and device is CUDA. We are going to keep things pretty simple, guys. We are simply going to ask the model, is the following sentence positive or negative? If it says positive, then we are going to append 1. If it says negative, we are going to append 0. And then we are going to evaluate it. That, okay, what was the actual label data? That it is positive or is it negative, and matching it with, okay? Simple as that. Now, this is exactly what we do with ChatGPT. Just I'm using an open source simple model here. That's it. Nothing different. We are generating the results here. This may take a while, because generative models take a while to generate results, and plus we have only a single GPU here. That's the problem. If you see, I think the RAM, yeah, GPU RAM is pretty less because this model was small. And you guys can do it with any model, right? If you guys want, you can even go to Microsoft Phi 3, Microsoft Phi, yeah, I think Phi 3.5 mini instruct. You can even try this with, like, it has a specific instruction that you guys need to follow. Yeah, something like this. Yeah, there's a specific instruction type that you need to follow. But yeah, it's not that hard. I think instruction 2 in 1 should be fine with it. So you guys can try this model also for this task, and you will see almost similar results, maybe even increase one, because I think Phi 3.5 is the best small language model in the market right now. Now let's do the evaluation performance, okay? Cool. Now if you see, we got an accuracy of 0.83. So if you see for this, because this is a small model, I am not expecting, it's 2 years old. You see here, the best results were 0.85 or 0.76. So embedding model won here, right? We got the best results using embeddings. But remember, this is a very simple task, and we have still not used the best models. We have used one of the best embedding model, but in terms of the generative model, we have not used the best one. So remember that. So yeah, guys, that was pretty from my side. We learned three to four techniques about how you can do text classification, and wrap up of how far we have come, right? We used to use the sklearn libraries and different libraries, and now we have multiple techniques of doing text classification, and it's a very important task when you're starting a journey in NLP and AI. So yeah, that was the purpose of this video. I hope you guys learned something new, and I will see you in the next one. Thank you and have a nice day.